Something in our universe is missing, and it could change everything we know about reality. For decades, scientists believed dark energy made up nearly 68% of everything. An invisible force stretching space itself, pushing galaxies apart, and shaping the cosmos on the grandest scale. It was the key to understanding why the universe's expansion isn't slowing down, but actually speeding up. But now, there are whispers among physicists that something strange might be happening. The force that has been accelerating the universe may not be as constant as we once thought. It could be fading, it could be evolving, or, in the most unsettling possibility of all, it could be vanishing. This isn't just a small tweak in our understanding of physics, it's a potential rewrite of everything we thought we knew about. The fate of the cosmos. If dark energy isn't as stable as scientists assumed, then the universe's future may not be the endless expansion once predicted. Instead, it could take an unexpected turn, one that leads to a far more dramatic and unsettling conclusion. What happens if dark energy disappears completely? Could the universe stop expanding and begin to collapse in on itself? Would time itself unravel? The mystery deepens with every new observation, and researchers are scrambling to find answers. Some propose that dark energy is a temporary phenomenon, something that emerged in the universe's past but is now beginning to fade away. Others suggest it may fluctuate over time, following rules we don't yet understand. And then, there's the possibility that our entire model of physics is missing something even bigger. Something lurking just beyond our grasp. Whatever the answer is, one thing is certain. If dark energy is truly slipping away, the consequences could be more profound than anything we've ever imagined. In 1998, astronomers pointed their telescopes at distant supernovae, expecting to see signs that the universe's expansion was slowing down. Instead, they found something shocking. The universe wasn't just expanding, it was speeding up. This discovery wasn't just unexpected, it was completely unexplainable. Gravity should have been pulling galaxies back together, but something was working against it, a force so strange and invisible that scientists had no choice but to give it a name: dark energy. Unlike dark matter, which is thought to be made of unseen particles holding galaxies together, dark energy is something entirely different. It's not clumped in galaxies or floating around like a hidden substance. It's woven into the very fabric of space itself. As space stretches, dark energy appears to be driving that stretching faster and faster, as if the universe is being pushed outward by an invisible hand. Without it, everything could have turned out very differently. The universe might have slowed its expansion, stopped, or even reversed course, collapsing back in on itself. Instead, dark energy seems to be winning a cosmic tug-of-war, overpowering gravity, and reshaping the universe's destiny. But what if we've misunderstood it entirely? What if dark energy isn't some constant, unchanging force, but something more unpredictable? If it were to weaken or disappear, could the universe suddenly change direction? Scientists still don't know exactly what dark energy is, only that it seems to be there, or at least it was. But if it's starting to fade, that changes everything. Could we be witnessing the universe shifting in a way we never expected? For years, dark energy was thought to be a constant, an invisible force stretching the universe apart at an ever-increasing rate. But cracks are starting to appear in that idea. When scientists measure the expansion of the universe in different ways, they get answers that don't quite match up. Some of these measurements hint at something unsettling. Dark energy might not be stable. It could be changing, evolving, or even fading away. One of the more unsettling possibilities is something called the phantom menace hypothesis. In this scenario, dark energy isn't just weakening, it's slowly dissolving, slipping away like a fading signal. If that's the case, the universe's expansion might not continue indefinitely. Instead of an endless, ever-growing cosmos, we could be looking at a universe that gradually slows down and possibly, one day, collapses in on itself. This idea isn't just theoretical. Some of the strongest clues come from deep space observations, including the cosmic microwave background radiation, the faint afterglow of the Big Bang. Large-scale galaxy surveys also suggest the force driving expansion may not be as constant as we assumed. If dark energy is truly changing, then everything we thought we knew about the universe's future is suddenly up for debate. Will space continue to expand forever? Or could dark energy flicker out like a dying flame, leaving gravity to take over? Could we be heading toward a fate we never saw coming? The more we look, the more questions emerge, and the biggest one of all remains unanswered. What happens next? If dark energy isn't constant, then the fate of the universe is anything but certain. Depending on how this mysterious force behaves, the cosmos could be headed for one of two extreme endings, both equally unsettling. One possibility is the Big Rip, a nightmare scenario where dark energy doesn't fade but grows stronger over time. If that happens, the force pushing galaxies apart won't stop at just stretching space. It will start pulling everything apart. First, galaxies would drift away from each other. Then, within each galaxy, solar systems would unravel as planets break free from their stars. Eventually, even atoms themselves would be torn apart, shredded down to their fundamental particles. In this scenario, the universe wouldn't just end, it would be dismantled at every level, leaving behind nothing but isolated fragments scattered through the void. On the other hand, if dark energy weakens or disappears, the universe might settle into a big freeze instead. Without the extra push of dark energy, space would continue expanding, but more and more slowly, until everything becomes so spread out that no new stars can form. Over trillions of years, existing stars would burn out, galaxies would go dark, and the universe would become a vast, cold emptiness, an endless stretch of space where nothing new happens, and time itself loses meaning. But could there be another possibility? Some scientists believe dark energy might not be leading us toward destruction, but instead toward a kind of cosmic rebirth. In a cyclic universe model, dark energy doesn't just fade away or tear the universe apart. It fluctuates, going through phases of expansion and contraction. If that's true, our universe could be just one chapter in an infinite series of universes, each one rising and falling like cosmic tides. So what's really in store for the cosmos? Are we racing toward a violent end, a slow and frozen death, or something completely unexpected? If dark energy is changing, the universe may have a future we haven't even begun to imagine. What if dark energy isn't real? What if, instead of being some unseen force pushing galaxies apart, it's actually just a trick of the universe? Something we misinterpreted all along? Some scientists believe that dark energy might not exist at all. Instead, the problem might lie in how we understand gravity itself. For over a century, Einstein's equations have shaped our view of space and time. His theory of general relativity describes how gravity bends space, how planets orbit stars, and how black holes warp reality itself. But what if those equations don't quite work on the largest scales? Some researchers suggest that instead of a mysterious force stretching space, the accelerating expansion of the universe could be the result of gravity behaving differently than we expect. This idea has led to modified gravity theories, such as MOND, modified Newtonian dynamics, and FR gravity, which tweak the rules of gravity in ways that could explain cosmic expansion. without the need for dark energy. And then there's an even wilder idea. What if the expansion we see isn't caused by any force at all, but instead by something deeply strange about space-time itself? Maybe the structure of the universe is changing in ways we don't yet understand, creating the illusion of acceleration when, in reality, something else is at play. If that's true, then everything we've been searching for, this mysterious, dark energy that supposedly makes up most of the cosmos, might not exist in the way we think. What if the biggest mystery in physics isn't about discovering some invisible force, but about realizing we've been looking at the universe the wrong way all along? The search for answers is far from over. If dark energy is changing, or if it never existed in the first place, then solving this mystery will take some of the most powerful tools humanity has ever built. Scientists aren't just guessing anymore. They're launching a full-scale investigation into the very structure of the cosmos, and the next decade could bring discoveries that rewrite physics as we know it. Leading the charge is the Euclid Space Telescope, a mission designed to create the most detailed 3D map of the universe ever made. By studying the shapes and distributions of galaxies across billions of light-years, Euclid could reveal whether dark energy is truly a constant or if something more unusual is happening. Meanwhile, the Vera C. Rubin Observatory will scan the night sky like never before, tracking the motion of galaxies over time to see if dark energy's effects are shifting. And then there's the James Webb Space Telescope, JWST, capable of peering deep into the early universe, where the first hints of cosmic acceleration may have emerged. Beyond telescopes, scientists are also turning to gravitational lensing, where the bending of light by massive objects can reveal how space itself is stretching. By carefully analyzing these distortions, researchers can measure how dark energy behaves across different eras of the universe. And then there's an even deeper frontier, quantum mechanics. Some theories suggest dark energy may be linked to quantum fields, hidden forces that operate on the smallest scales but somehow shape the entire universe. If that's true, understanding dark energy could mean unlocking entirely new laws of physics. Will we finally crack the mystery in our lifetime? Could one of these experiments hold the key to explaining why dark energy seems to be disappearing? The answers might be closer than we think. But if history has taught us anything, it's that the universe rarely gives up its secrets without a fight. What if we never solve it? What if dark energy remains one of those cosmic riddles that humanity just isn't ready to understand? For all our telescopes, equations, and theories, the universe has a way of keeping its biggest secrets just out of reach. If dark energy continues to defy explanation, it could mean that we're missing something far bigger, something buried deep within the fabric of reality itself. Some scientists believe that dark energy could be a hint at an entirely new layer of physics, one we haven't even begun to grasp. Just as Newton's laws once seemed absolute until Einstein's relativity reshaped our understanding of space and time, dark energy might be pointing toward another revolution in physics. Could it be connected to extra dimensions, hidden forces, or even the true nature of space-time? If we fail to explain it, we may have to face an unsettling possibility that our understanding of the cosmos is still in its infancy. And that raises an even bigger question. Are we simply not advanced enough yet? Throughout history, there have been mysteries that seemed unsolvable until science caught up. There was a time when people thought the stars were fixed in a celestial dome, that space was empty and motionless. What if dark energy is another piece of the puzzle that only makes sense with knowledge we don't yet have? Could it be that we're standing at the edge of something profound, but just can't see it clearly? Perhaps dark energy isn't just a missing force. It's a breadcrumb leading us toward an even greater mystery. If we never solve it, maybe it's because we're asking the wrong questions, And maybe, just maybe, the answers waiting for us are beyond anything we've ever imagined.